off her 16th season, here she is now, Ellen DeGeneres.
Thank you. Thanks for being here. You know, on the show, what I like to do is I like to entertain. I also like to inform, because I don't want you just to be entertained. I want you to walk away learning something, so that's why a lot of the times I'll tell you about new studies that come out, or a new poll, or if I'm hungry, maybe a pie chart. There's always a new study. I don't know why we have so many studies. Someone should definitely do a study on that. I read something a couple days ago on an article about this guy named James Hutton, and something to do with the enhanced rock cycle. I had to learn more, so I contacted him as soon as I could. Everyone, please welcome James Hutton to the show.
Hey, feeling good, like I should.
Thanks for having me. It's so great to finally meet you. Glad to meet you too. Tell us a little bit about what you've done. Yeah, so before I became a geologist, I was very interested in chemistry and physics. That led me to studying geology. Recently, my theories of geology helped me to establish geologic time, more specifically, deep time. I recently proposed the idea of the rock cycle. The rock cycle? What's that? I didn't read that in the article. Didn't God create rocks? Yeah, so tell us about your studies on the rock cycle. I'm really curious, and I'm sure the viewers are eager to learn something new, knowing that they're one of the first few people to hear about this. Yeah, so the rocks we see outside have been around for millions of years and have been formed and changed by the rock cycle, which is basically the process of replacing old rocks with new ones. God didn't just drop them down. Wow, can you tell us more about it? Yes, so there are 4 types of rocks: intrusive igneous, extrusive igneous, sedimentary, and metamorphic. I guess we can say that the cycle starts with intrusive igneous rocks. Through the eruption of magma, these intrusive rocks become extrusive igneous rocks. Then, through weathering, erosion, deposition, and burial and lithification, these rocks become sedimentary rocks. From here, sedimentary rocks can go on of 3 ways. Sedimentary rocks can uplift due to mountain building, undergo metamorphism and become metamorphic rocks, or melt and become intrusive igneous rocks all over again. Intrusive igneous rocks can also go through metamorphism and become metamorphic rocks as well. In the end, metamorphic, sedimentary, and extrusive igneous rocks all go through melting and become intrusive igneous rocks all over again. From your knowledge, which rock do you think will break up the most? In my experiment, we will be working with granite, basalt, soft sandstone, chalk, and limestone. My hypothesis is that out of these rocks, the chalk and soft sandstone will break up the most. Chalk and soft sandstone are very similar. The chalk we use contains soft sandstone. These rocks are very fragile because they are made up of sedimentary rocks. They have gone through all the processes of the rock cycle, making them weak. Hi, my name is James Hutton, and after discovering my theory of the Earth, I have come to the conclusion that sedimentary rocks originated through a series of successive floods in the rock cycle. I recorded the gradual actions of geomorphic processes like weathering and erosion, and I have a great way to teach it to the world. The purpose of my DIY weathering experiment is to find out which type of rock falls apart the most after it has been frozen several times. To begin this experiment, I'm going to fill the container up with water and put it in the freezer for 2 days. I will repeatedly continue this process until the rocks are all cracked. I will get back to you with the results in 48 hours. Okay, so it's now the 2nd day, and as you can see, the chalk has been completely broken up. Parts of the granite have came off, and the basalt, there's been a little bit of discoloration, but other than that, the soft sandstone and limestone are completely fine. So we're going to put it back in the freezer, and then I'll get back to you in another 2 days. It's now day 4, and we can see that the chalk is just like all dissolved in the container, and the granite has like become more of a lighter color, and so has the basalt. And then the soft sandstone hasn't changed, and the limestone is becoming like a bit more gray. So we're gonna put it back in the freezer, and then I'll get back to you in another 2 days. Okay, so it's day 6, and the chalk is just still like all broken up in the container. The basalt is starting to become like more of a white color, and the granite is like starting to chip off a little at the end, and the basalt is still getting darker, and the soft sandstone just hasn't changed yet. So we're gonna put it back in the freezer. So it's now day 10 because I decided to keep the rocks in the freezer for 4 days instead of 2 days because they weren't really breaking, like only pieces of it were coming off, but it wasn't a lot. And it actually made a pretty big difference. So the granite started chipping from the very bottom, so it's now into 3 pieces. The basalt chipped at the bottom also. The soft sandstone broke up into 3 pieces. And the basalt just hasn't changed yet. So I'm gonna put it back in the freezer for another 4 days, and then I'll come back to you with the results. So after keeping the rocks in the freezer for another 4 days, almost every single one is basically broken, but not fully. So the granite is kind of hard to break. It hasn't really broken up completely, but still parts of it are in the container. The basalt is also broken up a lot more this time. Soft sandstone is in 3 pieces, and the limestone only chipped off a bit, and then the chalk has been dissolved since like the first day. So we're gonna put it in for another 4 days, and that'll be the last time for this experiment, and I'll get back to you with the results. So it's now day 18, which is the very last day of this experiment, and the point that I was trying to get across was that rocks would eventually break over time with weathering and erosion, and the point was successful. All these rocks are broken up in some sort of way. The limestone was the hardest to break. It only broke into 2 pieces. The granite broke up into several pieces actually. The basalt broke up the most. And then other than the chalk, the soft sandstone was the easiest to break. Although it only broke into 4 pieces, it started to do this a while back. And then obviously the chalk has been there for a pretty long time. So thank you all for watching this experiment. It took a lot of time and knowledge to get this concept together, but it did end up working, and I hope people see geography in a whole new way across the world.
How does this experiment relate back to the rocks outside?
This experiment showed that over time, freezing and thawing of water will break the rocks. The water exemplifies the weathering process of the cycle. Over time, rocks near bodies of water will break apart.
Now, I have a question for the audience. Was James' hypothesis correct? Now, before I let Mr. Hutton go, do we have any questions from the audience? You over there.
Oh my God, Ellen, I love you!
Oh my gosh, I hope she's fine. I love my fans, but I have to pick someone else.
What would happen if we were doing this experiment in a glass container?
I would stay away from putting glass in the freezer, especially for this experiment. When you freeze water in a glass container, the frozen water will expand and it will break the glass container.
Okay, now that's all the time we have for today. Thanks again for coming down to the show. Next time you discover something, please contact my staff so we can get you back on here.
Thanks, Ellen. I appreciate you inviting me here. I had a lot of fun.
watching Ellen on YouTube. Hit subscribe to stay tuned for our next video. Next time on Ellen, we'll have a special guest, Howard Cappadocia, singing Pangea. Here's the sneak peek.
Drift. Pangea.
Continents are drifting. Mountains, they are uplifting.
Feeling good.